Okay, for question 9, again, I want to check whether I selected this question to check whether you are able to describe this graph and what it means to the marker, which many of you are able to. So for this graph, somehow you are able to see that you need to break the description into 3 parts. Many of you are able to tell me that for the yellow part, there's no power output. For the purple part, that the power output stays constant at 0.6 megawatt. But many of you, when you are describing the yellow part, you forget this very key word, linearly. So unlike biology and chemistry, when their focus is just y increase, x increase, for physics, right, we are actually more affiliated to mathematics. So we expect you to tell us whether it is linearly or non-linearly. We just need these 2 keywords. Okay, and if you look at the number of answer line and the number of marks, it seems to suggest that they want you to dig out more information. So if I have the bandwidth, I would have calculated the gradient of the green color part for the question as well. Okay, but I'm not going to spend too much time talking about this, whereas I want to spend more time talking about this part of the question. And basically, for convenience sake, I have dragged down the graph as well. So for this question, most of you are having trouble, and again, I just want to stress don't feel too disheartened, because the question I select is supposed to challenge you guys, because you guys are being selected for this subject group because you are able to answer the standard content based kind of question. But when it comes to database, when it comes to graph, data being represented in a graph, you all have difficulty interpreting. So that's why the question I select is all this kind of question. So when you are doing this, you will find that you are being challenged, you are being stretched. So don't be disheartened, right? Just like learning how to ride a bicycle, you need to fall a few times first. So here they are asking you, can you estimate the total amount of energy produced in a 10-minute interval? So many of you resorted to actually multiplying either the time. So many of you can code this formula, right? Which shows me that you know that I have to find energy. The problem is with the time, right? Many of you, when you see that it is a 10-minute interval, either you substitute 10 here or you substitute like this fellow 9. Actually, both are wrong. Because if you are substituting 9 minute or 10 minute, it means that you are not interpreting the context. What does the context say? What does this table say? This table is trying to tell you that only at the second minute, it is able to receive enough wind that will actually give you certain power output, right? Before the 2 minute, can the wind speed able to is the wind speed able to give you any power output? No, right? It is 3 and 2. So if you have a wind speed of 3 and 2, you belong to here, correct or not? So only at about 16, right, you are able to get 0.6 megavolt over here, right? 0.6 megavolt over here. Then again at here, there is no power output. Then at here, you are going to get some power output. Here, you are only getting some power output. Then after that, at the 10 wind speed of 10, so wind speed of 10, you are going to get 0.3. So here you are also going to get certain power output. So how many minute have you how many minute does your wind turbine able to give you a power output? Is it the full 10 minute is able to give you some power output? No, right? The wind turbine can only give you a power output for actually the duration of 6 minutes. Right? Some of you, the more mathematical affiliated, you no, this is not 6 minutes, it's 5 minutes. Okay, 5 minutes, 6 minutes, up to you. Right? Let's not go into that kind of nitty-gritty. Do I start counting from 0 or 1? Right? This is physics. We want to check whether you can interpret the data. So if you just look at this, you can argue the time that the wind turbine is generating power is 5 minutes or 6 minutes, but definitely not 10 minutes or 9 minutes. So those of you who multiply by 9, multiply by 10, definitely they are going to penalize you because you are not interpreting the data. you are just looking at the question and you see that, oh, there is a 10 minute here, so I time 10. So that's where you get wrong. So how should I attempt this question? Well, very simple lah, right? You just ask yourself, okay, within these 2 minutes, this is my assumption ma. So when I interpret the data, I will have certain assumption, right? My assumption is what? Oh, for the second minute, the whole second minute, the wind turbine receive the wind power of 16. So what is the energy that have generated here? Well, the energy that generated within this second minute will be E equals to power mega times time, which is 60 seconds, correct or not? Then I will say that, oh, this E is equals to 0.6 mega times another 60 seconds. That is my interpretation. Then some of you will say, no lah teacher, I think they are saying that between the first minute and the second minute, then something happened. Okay, I leave it to you. You can interpret it that way also. Why am I so confident that it is open to interpretation? Because as I read, I saw this thing. Explain why your answer to part 2 is only an estimate. What does this mean? This means that Cambridge know that you can interpret this table in two different manner. The first way, I can say that, oh, at the second minute, the whole minute, the wind turbine receive 16 meter per second of wind, and as a result, it generates 0.6 megawatt. Well, I can interpret, right? That's why I say that when you are attempting the question, let's say you are stuck here, you have a certain doubt, just look at the next one and you see that, oh, I can estimate. Then in that way, I estimate the easiest way, I just estimate that, oh, for the third minute, the whole minute, right, the wind speed is 16. So back to the first question, how do I find the total energy generated in this 10-minute interval? 10-minute interval, here it says 10 minutes. So what does it mean? This is the first minute, second minute, third minute, 4 minute, 5th minute, 6 minute, 7 minute, 8 minute, 9 minute, 10 minute. Okay lah, then I can interpret it that way. It makes sense ma. Correct or not? So how many energy it generated? Oh, so I already accounted for this guy and this guy, right? So the next thing is that I will go and interpret for the rest of the guys lor. Don't here, I will just take this. Of course, you can't do it lah, but in your mind, you can do copy and paste, right? So I will do this, right? Then I will just do for the 6th minute and the 7th minute. Then after that, I also do it for the 9th minute and the 10th minute. But this time round, it is no longer 0.6, it is 0.3 lah. Right, so if I sum up all of this, I will be able to answer this law. And what is my assumption? My assumption is what? Oh, within these 2 minutes, my speed is constant 16, no change. Is it an assumption? Of course, assumption since when wind speed so constant at within 1 minute is always 16 one, correct or not? So I can use that as my answer. But instead, many of you are telling me what? You are using template answer. The reason why you are stuck at A2 is because when you are asked to use an estimate, you always go to what? Oh, why is it an estimate? Heat loss. No. Heat loss already accounted for because this thing measures what? These things already measure the power output. What does this mean? Well, the energy from the wind is your energy in, right, by your wind. It goes into your wind turbine that looks like a flower, right? Okay, some is heat loss, some is lost by sound because wind turbine are noisy. Then after that, one goes to power output. So the power output that is being measured here have already accounted for whatever energy that is lost. So for example, if this one is 100 joules, this one is 20 joules, this one is 40 joules, people already accounted for your power output is 40 joule. So when the question asks you, what is the estimate that you have, what is the estimate in your answer in 2? You cannot say that, oh, my answer in 2, I haven't accounted for heat loss. No, heat loss already accounted for. Understand? So down here, we cannot accept your heat loss, sound energy loss, air resistance, all these are already accounted for over here, right? You will all because of because of air resistance, blah 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 blah, friction between the gear and the wind turbine, all these things already account for, because you are directly measuring the output already. Yeah, so down here you can say that what is a estimate? Well, you have estimated that within that 1 minute my wind speed is always 16, right? No change. Well, not very accurate. What it has to be a estimate, right? Okay, then down here for your 8A, I'm not going to spend too much time, because it is a standard way. You just apply your V equals to IR to the lamp, you'll be able to find the main current. Then you apply V equals to IR to the whole circuit, because it's a simple series circuit. You'll be able to find the total resistance. Okay, but for your part B, I will spend a bit more time on this. So for your part B, what happened is that you need to be able to recognize that this is like your resistance wire lah, right? They are saying that for your resistance wire, the whole wire is 10 ohm, right? Then after that, you have a jockey over here that you can slide over the start of your resistance wire or the end of the resistance wire, but they tell you that the whole wire is 10 ohm, right? Then after that, they kind of describe over here that if you have XP like that, so you can imagine this like, this is like the whole thing, right? Then after that, you have your resistance wire here and your resistance wire here, right? So you have two part like that, right? So either you can imagine it as a resistance wire case, or you can just break your box into two boxes. One box, you can call it XP, right? And they already tell you that this XP has 3.2 ohm. Then they also tell you that the lamp is 3.2 ohm. So if you look at this circuit, it's basically you have this parallel part, which you can find like this. Then after that, after you find the parallel part, it becomes in series with this, which then you can just sum it up like any series circuit. So most of you are able to calculate this. It is part 2, which is actually the stretching question, which I will spend more time doing it. So for your part 2, they are saying that the slider X is at A, and then you have slider X at B. So the circuit become like this. So you have these two. Okay, one is that the slider X is all the way past the whole at the end of the resistance wire. So the current will flow through this entire resistance wire, and that's at A, right? Then after that, the other one is that the slider is right at the beginning of the resistance wire, like that. So far, okay? So then they want you to actually find the potential difference across the lamp. So basically, they just want you to find the V of the lamp. So if you look at A, I think most of you got it correct. It is basically a parallel circuit, right? So if you have 12 volt here, it means you have 12 volt across the resistance wire, and so you have 12 volt across the light bulb. Okay, notice what I said, 12 volt across. Somehow in your answer, my class, Mr. Chew's class, Mr. To's class, voltage flowing through voltage don't flow one. Then some of you, voltage of light bulb. Light bulb don't have a property called voltage one. Okay, or voltage in a light bulb, or also voltage cannot be inside things. So the only preposition you have to use for voltage is across, right? So that's for A. So for A, most of you got it correct. It is indeed 12 volt. How about at B? Or at B, then is quite interesting. Can you see that down here, there is a junction? So if there is a junction here, okay, it doesn't matter the current go this way or the current go this way one. So for convenience sake, okay, I will just swap this thing. Yeah, when you analyze circuit, it doesn't matter how the current flow on. Okay, but I know that it matters to you guys because that is the way you all are trained in lower set. So let's say the current go like this lah, okay? Let's say it will go to this junction. Then now it has two path. The blue path, which is this way, or the black path, which is this way. Then remember you learn something called a short circuit. Okay, this is a short circuit, right? This thing is basically your short circuit. So for a short circuit, what does it mean? The current will just take this path, go through this resistance wire and come back here. To the circuit, this entire light bulb no longer exists, right? Because you have short circuited, right? Will the circuit overheat? No, it won't overheat, right? It won't overheat. Why it won't overheat? You say short circuit, well, short circuit always overheat. Yeah, short circuit will overheat if the energy carried by the charges is not being used for meaningful work. Okay, for example, if you have, let's say, something like that, and then you have a light bulb like that. This short circuit will overheat because the current will just go like that, right? You can see that the current is not doing any meaningful work, right? So whatever energy that the current is carrying will turn into heat, it will overheat, cause a fire. But for this particular case, there is actually a resistance wire here that is worth 10 ohm. So because of that, the resistance here is not 0. There is still a 10 ohm resistance here. So for this short circuit, it is still safe, right? Because the effective resistance of the circuit is not 0. So it won't overheat. But then your light bulb will not light up because no current will flow through that path. So actually because of that, down here, your light bulb will have 0 volt. So that's how you get your 1 mark. It's difficult. Okay, but that is why we are training you. You are the group that we want you to answer all these stretching questions. How about part 3? Part 3, you just look at the question. 3 answer line, 1 mark. If I were you and this is the last few questions, I'm tired, I will skip. Later I come back. Okay, but let's say I want to attempt this question. How should I attempt? Advantage. I need to figure out the advantage. About the control the brightness. How should I do this? Very vague, very hard. But there is actually a shortcut way of thinking to attack this kind of question. And that's why this subject day is meant to teach you. If let's say in your mind, when I first read this question, in my mind it is blank. I don't know what to do. Then I will use this way of thinking to help me approach this question. The way it is approaching this question is, this question, the hint lies in the previous question. It must be. So I look at this. I see what? PD across the light bulb. If I can control the PD of the light bulb, I can control the brightness of light bulb, right? Because I know that the brightness can be given by V square over R, right? So if I want to control the brightness, the R of the light bulb is constant. I just need to control the V. How come the last question, without reason, go and ask me to find voltage? Then now in the second part, ask me to comment on the control of brightness of the lamp. Fishy, sus. So immediately I see that, wait a minute. This one is the figure 8.2, right? This figure 8.2, the light bulb voltage can be from 0 volt to 12 volt. Okay, let's look at figure 8.1 because fishy, right? Let's look out for the voltage of the lamp. 8.1. This is 8.1. Voltage of the lamp. What does it say? I go and do all this calculation. Wow, piang, I forget already and my brain burn already. So when I first encountered this question, my brain also very tired. In fact, I finished marking so many scripts. How can I remember all this? Correct or not? So I will use this method again. What information have I not used? Because all information given in paper 2 must be used. So I do by calculation. Okay, I look at part 1. Part 1, I use 2.9 and 3.2. 2.9, 3.2. I use this, I use this, I use this. Then what did I use? I use 12 volt. Okay, I use 12 volt. What else did I not use? I have not used this thing, right? What resistance, So that, PD. I am comparing about PD. Here got talk about PD. PD of the lamp is between what? What? Let me see again. PD of the light bulb decreased from 12 to 2.9. Haha. Figure 8.2. PD of lamp 0 to 12. Figure 8.1. PD across the lamp. Right, 12 to 2.9. Advantage is what? So let's write everything together. Now I find it already. So for figure 8.2, the voltage of 8.1, 8.1, sorry. 8.1, it is 12 to 2.9, right? Cannot be the question so good. Suddenly go and mention this PD across the lamp between 2.9 to 12 volt, right? Must be for some reason. Hey, what did I see? I see that 8.2 can go all the way to 0. 8.1 can go only to 2.9, meaning what? Meaning 8.1. Some more don't have a switch. Meaning what? 8.1, the lamp always on one. Correct or not? So what is the advantage? You tell me now. Can see? And when I approach this question, similar like you, I don't have a clue. But I know this trick. When I am supposed to answer part 3, the hint has to be in part 2. That's why they are called part 2, part 3 ma. So I look at part 2, I try to create a correlation between PD of the lamp in part 2, control of brightness in part 3. Once I find something that I can zoom into, suspicious, I go to 8.1. 8.1, wow, a chunk of calculation which I have forgotten what I'm doing. I go and search in the context, what are the parameters that I have not used. I will be able to find. Because this parameter is useless in this calculation, it is meant for this green color thing, is actually meant for this part. So immediately I will be able to find. And this technique is the thing that I want you to learn from the subject day. Right? How do I approach a question that I have no clue on how to solve? Right? That is what I want you to learn. Okay? So how to answer this is just 1 mark, 3 line, easy phrasing. 8.2 can reduce the PD to the lamp, and hence you can off the lamp. 8.1 you cannot off the lamp. Okay, so I'm not going to type it out for you. Okay, I will discuss the last question in my last video. So I hope you really learn on these 2 tricks, very important.